Rukmani, working as an associate professor in the Department of EIE at Sri Ramakrishna Engineering College. Today we are going to see about reading temperature data using thermocouple DAQ with Python. These are the content we are going to see in this session. Thermocouple. Thermocouple is a sensor which is used to measure temperature in industries. It consists of two dissimilar metals form a junction is called as hot junction and cold junction, which is used to measure the temperature of a medium. Based on the materials combination, variety of thermocouples are used in industries. Most widely used thermocouples are J-type and K-type thermocouples in the range of 0 to 1260 degrees Celsius. LabVIEW. Why we go for LabVIEW? When compared to other programming language, it is a graphical programming environment which allows user to design and analyze any complicated system with a shorter time period compared to the other systems. LabVIEW graphical programs is called as VI, simple virtual programs, which is used to automated product design, validation, component checking, control and monitoring of devices, condition monitoring of any equipment used in industries. What is Python? Python is a popular interpreted programming language which is used in all type of industries. It is a multiple examples from LabVIEW that demonstrate how to set your block diagram and call your Python code. That is, we have to create a block diagram in LabVIEW environment and we call the program in the Python mode. Data acquisition system. DAQ system is most widely used in LabVIEW in the process of measuring electrical and physical parameters such as voltage, current, resistance, temperature, pressure, sound, torque, etc. DAQ system consists of four main parts: input-output signal, data acquisition hardware, PC, and software connected to a system. Input may be analog in nature or digital in nature, or real-time data from the signal that may be analog or digital. So DAQ consists of both analog input-output port and digital input-output port that is connected through USB to a PC. So these are the four main parts: physical input-output, sensor, DAQ device or hardware, driver software, application software with Python. Now we are seeing how the LabVIEW environment is connected to a thermocouple. Now, NI DAQ Max is a communication protocol which is used to control NI data acquisition device with hardware to solve the real-time problem. Now, NI DAQ Max can be used to support C, Python, and C Hash. Now, we most widely use Python for solving the problem. NI DAQ MX is used to connect the hardware with Python environment to a system. With that, here we are using a K-type thermocouple where two dissimilar metal, chromium and aluminum, is connected. This is hot junction T1 and this is cold junction T2. This is DAQ, data acquisition system 9162. It's especially for thermocouple connector. Here we are having a analog port, 16 analog port and 16 digital port, where we are connecting a real-time sensor to a system. Here we are using analog port 1 and 0 connected to a thermocouple. We see two approaches. First, we connect a DAQ assist to show the temperature variations in the thermocouple. Now I am going to run the system. So here the room temperature is around 34 degrees Celsius is displayed. Now I am varying the temperature thermocouple. This shows the variation of temperature with respect to time. This is one way we are using DAQ assist tool to measure the temperature of a room temperature using thermocouple. Here we are going to see about the DAQ Max, which is used to connect LabVIEW with Python. Here I am using DAQ Max, which is used to connect the temperature. Here as device 1 is nothing but thermocouple, and here I am measuring the temperature, and we want to create a waveform, and this will be the output. When stop button is enabled, the total system will do. Now I am moving to on the system. I have to select the device port, device 200, and now I'm turn on the device. Here I am having a room temperature. If I vary the temperature using thermocouple, the fluctuation is nothing but the variation from every second. Each second by second, we are measuring the temperature using DAQ assist. The same DAQ assist is connected to a Python code to measure the temperature. Here I am connecting a channel TC01. It is nothing but thermocouple connected to now I am calling the function name to assign the values. So every time I am measuring time versus thermocouple output in temperature. So I am calling the function task read and then task stop, where we have to start the reading and we have to stop the reading, giving the timing signal to the Python code. Now I run the Python. For every seconds the readings will be displayed, and finally the print the value will be displayed from every second, and after 10 to 15 hours we will tabulate the reading, temperature in degrees Celsius as well as time, and finally we plot the graph between time versus temperature. So real-time data from the LabVIEW environment will be converted into a Python environment. This graph shows the relation between time versus temperature of a thermocouple. These three are interrelated. When we go for LabVIEW platform, Python for longer time. We use DAQ assist only for minimum time period application. We use DAQ max, and Python is for continuous reading. The same readings can be tabulated and using ML and DL algorithm to analyze the variation in temperature time to time. Thank you.